Okay, so now we're in a situation where we are actually dividing two power series. And so the power series that we're in the numerator, we already mentioned this before, last time we mentioned this. Uh, the power series in the numerator is actually sine of x. We're going to learn about this next week in class. Okay, so just like 1 over 1 minus x is this power series here, x to the n is the geometric series, and it's valid on negative 1 to 1. Sine of x is equal to this power series, and it is valid on negative infinity to infinity. So it has it converges everywhere. And more importantly, it converges to sine of x. And then the series on the bottom is actually cosine of x. So the f of x that we're working with is actually tangent of x because it is sine of x over cosine of x. So here's the idea. Imagine if you knew the power series for sine of x and the power series for cosine of x, you could then figure out the power series for tangent of x by using long division on your power series. Okay, so as usual, the first step when we're dividing or multiplying power series is to write out the first few terms of the series that are involved. So here we've got the first few terms of sine of x, okay, and then over here I've written down the first few terms of cosine of x. And always it's very, very important for you to write plus or minus dot, dot, dot. If you just leave it like this, that is incorrect, right? Because what's on the right is a polynomial and what's on the left is an infinite power series. So you always have to indicate dot, dot, dot if you're going to write out the first few terms, okay? So now, let's see here. So how are we going to divide these? We're going to divide them just like how we would divide polynomials. Okay, so perhaps we need to do a kind of a reminder. If we wanted to divide, let's see here. So just as a reminder, if we wanted to divide x squared plus 4 by x minus 2, what would we do? Well, we would set it up like this, x minus 2, and then this is x squared plus 4, and then we would see what, I would take the leading term of this x minus 2, and I would see how many times does it go into the leading term of x squared plus 4. So I'll say, oh, okay, I need to multiply by x. Now x times x gives me x squared, and then x times negative 2 gives me negative 2x. Then I subtract all of this, and I would get x squared minus x squared gives me 0. 0 minus negative 2x gives me 2x, and then 4 minus 0 gives me 4. Right? Does that sound familiar? Okay, here's the key. Is that you got this like plus 0x plus 4. Right? And then here on the bottom, it's like plus 0. So now it's just what's x squared minus x squared? Oh, that's 0. Okay. 0x's minus negative 2x's, 2x's. 4 minus 0, 4. Okay, and then we do it again. So we say, how many times does x go into 2x? Oh, plus 2. Okay, now plus 2 times x is going to give us the 2x. And then plus 2 times negative 2 is going to give us negative 4. So we would subtract and we would get, okay, 4 minus negative 4 gives us 8. So then we would say, okay, so our quotient is x squared plus 4 over x minus 2 is equal to x plus 2 plus 8 over x minus 2. All right, okay, so that's just a quick reminder, and that is the procedure that we're going to use here. So in my numerator, oh, okay, wait. So remember, if we had x squared plus 4 over x minus 2, then we put x minus 2 into x squared plus 4. Okay, so here I have x squared, command copy. So I've got this numerator here, and I want it to be divided by, over here, what do we have? I'm just going to copy and paste. Copy, paste. Okay, so this is going to equal so let me move all of this over. And this is going to be equal to 1. Let's get large so we can see what's going on here. So it's going to be equal to 1 minus, so we have 1 minus x squared over 2 factorial plus x to the 4 factorial, x to the 6 over plus x to the 8th over 8 factorial. And this we're going to divide plus dot dot dot, divide it into x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus minus dot dot dot. Okay, so now let's go ahead and, because it's kind of weird to work with these numbers as factorials when we're dividing, because it'll be iffy, so here's how I'm going to simplify things. Number one, I'm going to erase those. So I'm just going to focus on the first, the first few terms. So I'm going to erase these. So we'll have plus or minus, minus plus, dot, dot, dot. So that should make life easier. And then number two, so we said we're not doing that. What is 2 factorial? 2 factorial is just 2. What is 4 factorial? That is 4 times 3 times 2. So that's 24. So I'll write that as 24 plus minus dot dot dot. And then on the inside here, right, let's delete that. Minus plus dot dot dot. What is 3 factorial? It's going to be 6. What is 5 factorial? 5 times 4, 20 times 6, which will be 120. Okay, so now, rewriting it a little bit, we'll have 1 minus x squared over 2 plus x to the 4th over 24 plus minus dot 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 goes into x minus x cubed over 6 plus x to the 5th over 120 minus plus dot dot dot. Okay, so first task is to see how many times does 1, so I look here, how many times does 1 go into x? X. Now I take x and I multiply it by all of these terms. So x times 1 is going to give me x. X times negative x squared over 2 is going to give me negative x cubed over 2. X times x to the 4th over 24 is going to give me plus x to the 5th over 24. Okay, now I subtract all of this, and in reality I should be saying plus minus dot dot dot. Okay, now x minus x, that gives me 0, that's what I wanted. Negative x cubed over 6 minus negative x cubed over 2, that is the same thing as negative x cubed over 6 plus x cubed over 2, which is the same thing as negative x cubed over 6 plus 3x cubed over 6. So we get 2x cubed over 6, which is x cubed over 3. Okay? And then we do that same process. What do we get here? So now now what is x to the 5th over 120 minus x to the 5th over 24? Right? Multiply the top and the bottom by 5. So we'll have minus 4x to the 5th over 120. And the 4 over 120 we can simplify as So it's 4 over 120 x to the 5th, which is the same thing as 1 over 30 x to the 5th. Okay, we've got plus and minus, whatever. Okay, now 1 goes into x cubed over 3 how many times? X cubed over 3. So we'll say plus x cubed over 3. Now I take that x cubed over 3 and I multiply it by each of these. Okay? So I'll have x cubed over 3 minus x to the 5th over 6 plus x to the 7th over 72. Now I'll get 0, and I won't belabor point 2 over 15, and then plus right? Because I don't know what term this is. I don't know what term this would have been, so I can't do anything else. I have to stop at 2/15 x to the 5th. Okay, one last time. 1 goes into 2/15 of x to the 5th how many times? It's going to be 2 over 15 x to the 5th. And so now I've got that, and I multiply 2 over 15 x to the 5th, then minus.
It's 1445.
Thank you. X to the 5th over x to the 7th over 15 plus blah 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 blah. But it doesn't matter because now I'm going to get plus or minus plus or minus . And so my conclusion would be to say this top right here. So tangent of x is equal to x plus x cubed over 3 plus 2x to the 5th over 15 plus . Okay? And again, know we'll set infinity for sine and cosine, and actually e to the x. So since they both have the same interval of convergence, which is negative infinity to infinity, their quotient also has that negative infinity to infinity.